Hi everyone. In this lesson, I'm going to talk about another special line segment in a triangle, which is known as the altitude. So here is a triangle ABC, and I've intentionally drawn it in a way that will allow me to illustrate the importance of an altitude. You can see that this triangle is an obtuse triangle. The altitude through B is the line segment that connects B to, so here's B, and it's going to connect that vertex to the opposite side, AC, but it has to join at a 90-degree angle. So in other words, if I'm just going to roughly do this, here's my altitude. That wasn't very good. Let's try that again. Here's my altitude, and that has to be a 90-degree angle. Okay, so that's fine. That kind of makes sense. And you might wonder if this length is the same as this length. In other words, is this line that I've drawn, is it the median? And in general, no, that's not the case. So I'm just going to undo that there. Now, to show you a better example, imagine what the altitude through C is going to look like. So C, I have to draw a line segment from C that's going to go through the line segment AB at right angles. Well, how's that going to work? If I were to draw such a line, there's no way that that's a 90-degree angle. It's not even close. So what I need to do in this case is I need to extend AB like so, and then drop down the altitude like that. Okay? So you can see in that case very clearly that the altitude from C is not the same as the median from C. The median from C, if I just roughly do this, would be the one that I drew the first time. That would be the median. That's not what we're after here. We're after something else. We're after the altitude. So this guy, is what we're going to be doing in this example. Start off with an example that has some numbers. So I've gone ahead and drawn a triangle, ABC, and I've chosen to put all of the vertices in the first quadrant, so just so that all of my numbers are positive numbers. Now here, this is, at least it looks like, an acute triangle. So really my altitude is going to be kind of like, normal looking, so to speak. But it doesn't really matter. The process is always going to be the same. So what I'm really after is I want the equation of my altitude. And that's what I want. Okay. Now whenever I want an equation, so an altitude, that's a line. Alright? And whenever I want the equation of a line, I need a point and a slope. Alright? I need a point and a slope. Now, the point that I'm going to use for my altitude depends on which altitude I want to find. In this case, I'm just going to arbitrarily choose the altitude from point C. So I want to find the altitude from point C. Well, that means that the altitude from C has to pass through the line that A and B are both on, right? So that means that the altitude, when I draw it in, I don't know exactly where it's going to be, but the altitude has to drop down and meet that line at a 90-degree angle. Okay? So the point that I want to use here has got to be the point C. I know that point is on this altitude. And the slope, well, I don't know the slope yet, but I know the slope is going to be perpendicular to the slope of line segment AB. So that's where I'm going to get my slope. So now I can write this up in a plan form. So here's my plan. step 1, I'm going to, since I know the point C already, I don't need to do any calculations with that, but I need to find the slope of AB, the line segment AB. My second part in the plan is I need to find the perpendicular slope to that. So I'll just write that as M perpendicular. And then step 3 is I want to use the point C and the perpendicular slope to write y equals mx plus b. That's my plan to find this altitude. Okay, so let's try and execute that plan. I'll need to zoom out a little bit to give myself some room. Not too much. Okay, so here we go. Step 1 of the plan. Now I'm going to execute this step. I'm going to write my t-chart. I'm going to put in the points A and B, and I'm going to work out the first difference so as to get the slope. So the slope in this case is slope AB equals 3 divided by 10. That's my slope. That was step 1. Excuse me. Step 2 in the plan, I want to find the perpendicular slope. Well, the perpendicular slope is just negative 10 divided by 3. Not too bad. And lastly, I'm going to put that together with the point C, and I'm going to write it in y equals mx plus b. So again, you'll forgive me, I'm going to move myself over a little here. Oops. Just a bit more room. Okay, step 3. I'm going to write y equals mx plus b. So I'm going to use the y of point C, which is 10, the perpendicular slope, which is negative 10 thirds, and the x of point C, which is 6. Okay, I will now simplify. This is going to be 10 equals, if I multiply this together, I get negative 20. And then if I isolate b, I get 30 equals b. So my altitude, therefore, is, let's write a little therefore statement, y equals negative 10 over 3x plus 30. And that's all. I could do the exact same procedure for another altitude. In this case, I'm going to do it through the point, or from the point A, I should say. My plan isn't going to change very much. So my plan, step 1, I need to find the slope of BC, that line segment. The second thing I need to do is find the perpendicular slope. I'll just write that as M perpendicular. And then lastly, I want to substitute the point A and the perpendicular slope into y equals mx plus b. Just like that. Okay, let's execute it. So step 1, make a t-chart. Put in the points. So one of the points was 6, 10, and the other was 12, 5. Then I'm going to do my first difference. So here I have 6, and here I have negative 5. So my slope of BC equals negative 5 divided by 6. All right, easy enough. Step 2, I need to find the perpendicular slope. So M perpendicular equals 6 divided by 5, right? The negative reciprocal. And then the last step is, I'll do it up here. I'm going to substitute into y equals mx plus b. I'm going to substitute the point 2, 2, so y is 2. The slope is this guy, 6 over 5. X is 2, and b I'm trying to work out. If I do my multiplication, I have 2 equals 12 divided by 5 plus b. And yeah, if I simplify that, I'm going to have 2 subtract 12 divided by 5 equals b, and I'm going to get negative 2/5 equals b. Not a super nice number, but that's okay. And lastly, I'm just going to write my equation. Therefore, y equals 6 divided by 5x minus 2 over 5. And that's it. That's my altitude. Okay, so I just want to point out that the plan is always the same, right? If you're asked to find the altitude from a particular point, you find the slope of the opposite side, you use that to get the perpendicular slope, and then you substitute in your point and your slope into y equals mx plus b. That's the plan. It works every time. Write this down if you need to, and we'll try some in class. See you then. Bye.